name is Guofang. The title of our paper is An Efficient Unsupervised Domain Adaptation Deep Learning Model for Unknown Malware Detection. We will elaborate on the following four aspects: motivation, method, experiment, and conclusion. Part 1. Motivation. Emerging malware and zero-day vulnerabilities present new challenges to malware detection. Currently, numerous proposed malware detection approaches are based on supervised learning. However, these methods rely on a large amount of labeled data, which is usually difficult to obtain. Moreover, since the newly emerging malware has a different data distribution from the original training samples, the detection performance of the model will degrade when facing new malware. Finally, domain adaptation can fully exploit the similarity between the source domain and the target domain, so that the knowledge gained by the model during training in the source domain can play a greater role in the target domain task. Part 2. Method. This paper proposes an unsupervised domain adaptation-based malware detection method to analyze the joint distribution of known malware and unknown malware. The overall framework of the approach is shown in the figure. It mainly consists of three components: feature extractor for extracting domain environment features, classifier for malware classification, and domain discriminators for domain adversarial learning. Moreover, the self-attention model is imported to extract local features more effectively. The distribution divergence between the source and target domain is minimized by adversary learning to learn shared feature representations. To obtain semantic information of unlabeled target domain data. This paper reduces the class-level distribution divergence by aligning the class centers of labeled source data and pseudo-labeled target data. To improve the ability of the model for extracting feature information, this paper mainly uses a ResNet with a self-attention model as a pre-trained model. The global domain alignment. The method employs the idea of generative adversary networks, in which the feature extractor plays with the domain discriminator during the training process. The domain discriminator is trained to distinguish between source and target domain features. while the feature extractor obfuscates the domain discriminator to learn a domain variant feature representation. The semantic alignment to make the model have higher classification ability and learn more depth features. We propose class-centered discriminable feature learning. By this way, we can make similar data more compact and dissimilar data more discriminable in the feature space. The semantic alignment training loss can be expressed as follows, where gamma is the trade-off parameter, n is the number of samples in a batch, m is the number of classes. This is the class center. R1 and R2 are two thresholds. This is the distance between the sample and its class center. This is the distance among the centers of the different classes. The class center updating. In our model, it is based on a mini batch rather than all samples in each epoch. Therefore, in each iteration, the class center is updated according to the following equation. At each epoch, the class center is updated if there is a sample of that class. Otherwise, it is not updated. Assign pseudo labels. During class center alignment, we need no pseudo label. So, first train the model with the labeled source domain data. We can obtain the pre-trained model. Then the pre-trained model is used to predict the labels of the target domain. The label with the highest probability is selected as the class label. Part 3. Experiment. In our experiment, the dataset includes male image, big 2015, and benign dataset selected from this dataset. The evaluation metrics include accuracy, precision, recall, F1 score. The implementation details. We used as follows: CPU, RAM, operating system. Optimism is Adam optimism. Learning rate, classification loss. Batch size is 32. Experiment framework is PyTouch framework. Experiment. In our experiment, we use a family of the malware dataset as the target domain and the remainder as the source domain. In addition, benign samples are included in the source and target domains, respectively. We take the labeled malware as the source domain and unlabeled malware as the target domain, and a transferable domain classifier is trained to predict the labels in target domain examples by the joint distribution alignment of the source and target domains. The experimental results are shown in Figure 3 and Figure 4. We can see from the figures that accuracy and recall of the bigger 2015 dataset percent 19.04 and percent 19.25 respectively. Moreover, the average accuracy and recall of the male image dataset percent 95.63 and percent 95.30 respectively. Additionally, we compare our method with others. From the table, it can see that our method outperforms the other methods. We transform the raw files into grayscale images before feeding them into the neural network. Moreover, our method achieves a higher accuracy and recall by jointly aligning the global and class distributions. It shows that the approach considering class information and semantic alignment has a better performance than the previous approach, only considering global domain adaptation. Part 4. Conclusion. In this paper, we propose an unsupervised domain adaptation approach to detect unknown malware by aligning the joint distribution, global distribution, and semantic distribution of known malware and unknown malware. To learn shared feature representation of the source domain and the target domain, the description of their distribution is minimized by adversarial learning. To obtain more accurately the semantic information of target examples with pseudo, we minimize the distance from the source and target domain to their class center. Especially, in order to improve the feature extraction ability of the model, we use a ResNet with a self-attention model as a pre-trained model. Extensive experiments were conducted to dataset, and the result showed that the proposed method outperforms the state-of-art detection method of detecting unknown malware. In the future, we will work on a more fine-grained domain adaptation approach of malware family classification. That's all. Thank you.